Next, we've got a concept that's called extrema. Extrema. These are basically our maximum and our minimum points, the highs and the lows. Now notice I've got two different phrases here. We have max and min points, and we also have max and min values. A max min point is actually going to be a coordinate. A coordinate. However, a max or min value, this is the y value only. We actually talked about this a little bit at the beginning of chapter 3. Remember that when we were dealing with quadratics, I would ask you for whether or not the vertex is a maximum and what is the maximum value. And on those, we only expected y value answers. How high, how low does it go? We also are going to talk about whether or not we have a local or an absolute max or min. Local versus absolute. Now, local just means in its own little neighborhood, where absolute means the whole entire graph. Look at the entire thing. So when I look at this particular example that I have right here, we have a couple of ideas. First of all, this is definitely a high place in my graph. And this is also a high place in my graph, although it's not the highest place in my graph. So that upper one we would call the absolute max, the absolute maximum. Why? Because over the entire graph, it's absolutely the highest point. The other little guy, this is just going to be a local maximum, a local max. And the reason we call it a local max is because he is a high point, but it's only in his own little neighborhood that it's a high place. Just in it, because there are higher places on the graph, so it's only in his own little neighborhood that he's a maximum. Now we also have a place right here. This is a low place in our graph. However, notice it's not the lowest place in our graph because our graph keeps going down forever and ever and ever. So we would call this guy right here a local minimum. In fact, this particular graph has no absolute minimum. It has no absolute minimum because it keeps on going down forever and ever. We will work these particular questions in class. There's one more thing I would like to talk about though before turning the video off, and that is the end behavior. The end behavior. What is happening out on the ends of the graph? Well, we already know what a quadratic looks like, and we know that a quadratic has an even degree, a degree of 2. So let's look at the second piece of this first, since we're sort of familiar. This kind of looks like a quadratic, our parabolas, but this is actually how all even degrees look. If my highest power is 2, 4, 6, 22, if my highest power is an even number, then both ends are going to go up or both ends will go down. There might be a whole lot of things going on here in the middle, but we don't really care about that stuff. We really only care about what's happening out on the ends. And we know from the quadratic that both ends go up when my leading coefficient is positive. So if the leading coefficient is positive, then both ends will go up. We also know that if the leading coefficient is negative, both ends go down. So that's for all even degree polynomials. Now let's go look at the odd degree polynomial. So a cubic would fall into this category, a fifth power, the highest power being a 7 or a 9 or a 75, as long as the highest power is an odd number. Again, there might be a whole lot of what I like to call wiggles in the middle. I don't really care about those. I only care about what's happening out on the ends. So what we're looking at for the odd degree, if the leading coefficient is positive, then overall, this guy is going to go uphill from left to right. It starts at the bottom and it ends up at the top. Overall, it goes uphill. The one that overall from left to right goes downhill, it starts at the top and it works its way to the bottom. This guy has a leading coefficient that's negative. So bring your notes to class. There's quite a few examples here that we're going to take a look at, a little bit more discussion that we're also going to look at, but for the most part, you need to understand the end behavior. You need to understand max and min points versus max and min values. You also need to understand locals versus absolutes. And then you also need to understand these first 6 definitions that I gave you about polynomials. We'll discuss the blanks when you come to class. See you then.